If possible, evaluate the infinite sum. 1 minus a third plus a fifth minus a seventh plus 1/9 minus 1/11, and so on. So it looks like we're alternating, so going plus minus, the reciprocals of the odd numbers. Okay, so let's just keep going. Now, if we wanted a particular formula, we could say they're adding up, so it's going to be 1 over an odd number. So if we start at n equals 0, we should be fine. All right. Oh, it's alternating, so we should have a minus 1 to the n. Yes, we start positive. Okay. So if we actually wanted to use sigma notation, we're all set there. Now, how do we evaluate something like this? Well, it would be good if we could find some power series. It doesn't have to be a power series centered at 0. But we could find some power series and some value x. So if you plug x in, you get this expression out and it converges. So let's think. Could we imagine a function? Is there one that we know that could apply, or one that we know that we might modify slightly to have it apply? Well, I'll tell you what this looks like. Arctan of x has a power series. And it looks like x minus x cubed over 3 plus x to the 5 over 5 minus x to the 7 over 7. Okay. It has individual single odd numbers. Now, you might say, well, are there others? Well, something that did jump to my mind as soon as I saw this was x minus x cubed over 3 factorial plus x to the 5 over 5 factorial, just because of the odd numbers. But then I thought, and I'm saying to you now, that, well, no, we've got single odd numbers, not odd numbers factorial. Okay, so sine of x wouldn't quite do the trick. Okay, but it was another thought in my head. Okay, you don't always jump to the exact right series right away. Sometimes you got to play around with things, and it's okay to do that. Okay, now arctan, its power series has interval of convergence from -1 to 1. So if I plug in -1/2 or 1/3 into this expression, it will converge. Okay. So, well, how can we match things up? We see the signs are all in order, so that's great. Looks like if we let x equal 1, which is perfectly fine, that's in the interval of convergence, then we'll have arctan at 1 is 1 minus 1 cubed over 3 plus 1 to the 5 over 5 plus 1 to the 7 over 7, and so on. Okay, so that works. So the answer is arctan at 1. Except we can do better than that. Okay, we're familiar with tangent. What angle gives me a tangent value of 1? This is a well-known angle. Okay. It's pi by 4. Okay, so the answer here is pi by 4. And if you want to, you can add up a few of these terms, get an approximation for pi by 4, multiply it by 4, and you have a good approximation for pi. Okay. But our answer here, our final answer is, yes, you can evaluate this because it's inside the interval of convergence, and the value happens to be arctan at 1, better known as pi by 4.